Okay, so now we wish to prove that sine 5 theta equals sine theta 16 cos to the power 4 theta, this is open bracket, minus 12 cos squared theta plus 1 close bracket. Now, what I'm going to do is first of all, I'm going to use c is equal to cos theta and s is equal to sine theta. Why? Because otherwise this can become extraordinarily large and cumbersome and will probably take away from the capacity to understand the structure. What I'm going to do instead is, say for example, you have cos theta plus I sine theta, I will use c plus is. We have proven that if, for example, you have cos theta plus I sine theta to the power 5, that power 5 can come in the form 5 theta plus I sine 5 theta. That's what we are going to utilize. So what I'm going to do then is I'm actually going to say that this right-hand side I'm going to expand considerably. So the left-hand side I'm going to keep the same, cos 5 theta plus I sine 5 theta. Why? Because that sine 5 theta is in here to the degree where I judge that if we go down the route of trying to keep that sine 5 theta in, we may end up with the solution necessary and have proven it to be true. So the right-hand side I can use Pascal's triangle, 1, 5, 10, 10, 5, 1, or I could do it in steps, but I judged Pascal's triangle is probably the best way to expand something like this. You see me doing it. The first part, c, will be to the power 5, then 4, then 3, then 2, then 1, then 0 in the expansion, and let's zoom in slightly here, we can take up more room here, and the s, the sine theta on the other side will be 5, 4, 3, 2, 1. That expansion has led to this c to the power 5, 5c4 is plus 10c cubed is squared, and so on. And I'm trying to take care not to make a silly mistake, and I judge I haven't, but if I have, I do apologize in advance. What's most important here is that the imaginary numbers, wherever there, for example, are a value, say for example, I have taken this 10c cubed is squared, so that I squared would be minus 1, leaving us with this minus sign in front of that structure. And you've got to be careful with those things in that mistakes can be made quite easily. This is not something that we tend to practice quite to the degree we should, considering how important it is when solving these problems. So this is this expanded. We have this situation here. I'm going to take only the imaginary parts, so you can see that there is an imaginary part, there is an imaginary part, there is an imaginary part, and the left-hand side in front of the I, that is imaginary. So we have this, and then I'm going to take all the imaginary sections. So here you have